The ideal gas law helps us relate pressure, volume, and temperature to an amount of a substance. So PV equals nRT. Pressure has to be in ATM. Volume has to be in liters. N is my amount, which has to be in moles. So if I'm given grams, I would need to convert to moles. R is the gas law constant. So R is always 0.0821. The units of R are liters ATM over mole Kelvin, which helps remind me that I need to be in those units. Temperature, of course, it always needs to be in Kelvin. So if I was to look at my first example, I'm given moles, which is my amount, N, 20 liters, and liters is my volume, 25 degrees Celsius, that would be my temperature. I'm looking for what is the pressure. So I'm looking for P. Well, I'm going to use the ideal gas law. So my pressure will have to be in ATM. That's what I'm looking for. My volume has to be in liters, and it is. N has to be in moles, and it is. Temperature has to be in Kelvin. So I need to convert my temperature before I can plug in my numbers. So we say 273 plus 25 degrees Celsius is 298 Kelvin. Then I can just plug in my numbers. Pressure is what I'm looking for, so that's X, times my volume equals N times R, which is the constant, times my temperature. Then it's just algebra, and you need to solve for what you're looking for. So we get 6.12 ATM. Here we're given 425 milliliters, which would be my volume, 24 degrees Celsius, which would be my temperature, and a pressure of 0.899 ATM, so that's P. I'm looking for an amount, grams of oxygen. Well, in my ideal gas law, PV equals nRT, I don't have grams, but I do have moles. So I'm going to solve for N, which would give me moles, and then I'm going to convert to grams. So a lot of times these take more than one step. Because I'm using the ideal gas law, PV equals nRT, I have to be in specific units. So my pressure has to be in ATM, and it is. My volume has to be in liters, so I need to convert 425 milliliters to liters. King Henry died unusually drinking chocolate milk. I'm going from milliliters to liters. So that's 3 places to the left. 1, 2, 3. Temperature has to be in Kelvin. So 273 plus 24 gives us 297. And then I can plug it in. My pressure times my volume equals my moles, which is X, times the gas law constant times my temperature. So that gives me moles. But I don't want moles, I want grams of oxygen. So I need to take my moles of oxygen and convert it to grams of oxygen before I can be done. So take my given moles on the bottom. I want grams, so grams go on the top. 1 always goes with mole. Oxygen's molar mass, 16 plus 16 is 32, goes on the top. Twenty 22.9 liters, that would be my volume. 2.7 grams of the gas hydrogen would be my amount. And 12 degrees Celsius would be my temperature. I want to know what is the pressure, so I'm looking for P. So I'm going to use the ideal gas law, and I want to be in specific units. Pressure has to be in ATM, but that's what I'm looking for. Volume has to be in liters, and it is. My amount needs to be in moles. So I need to take 7.2 grams of hydrogen, grams of hydrogen to moles of hydrogen. 1 mole, the molar mass of hydrogen, 1 plus 1 is 2. 3.6 moles. For the temperature, I'd want to say 273 plus 12. And then I can plug it in. Pressure is what I'm solving for. Volume is 22.9 liters. My moles, 3.6, times R, the gas law constant, times our temperature. And then we do some algebra.